Hello everyone, this is my lab 3 assignment. For this lab we built RGB to hex converter. What this does, it has 3 potentiometers to measure a value from 0 to 255. This is also the numerical equivalent for RGB color. It would have a number between that range for the red, for the green, and the blue, and it therefore creates all other colors. So what we're doing is changing the values so that we can approximate different colors based on their value of how much blue or green or red they have. So if we change the values, we can see that dimming increasing, representing that it has more color. Please don't mind that flashing is that when the knobs come out, they're coming out, and when they completely leave, then it just breaks. It flashes to 100. Okay, there we go. So we have a value there. We see our red. If we see the knobs, we see we have a lot of red, a little bit more of green, and then just a little tiny bit of blue. So that would be like red and green, I don't know, like orangey kind of color. So what happens to configure that, we would first configure the LEDs, and what we do is put the cathode or the negative pole of the light to the ground directly. Then we would, from the positive pole, connect it's not a 10K, it's it a 220? All right. Yes, yeah. So it would be one of these, a 220 resistor for each LED. There you go, excuse me. So you see, there are the resistors, each one resistor from the positive light to a new row, and from that row then we connect to the positive pole of the breadboard, and then on the first slot where we placed on the slot where we placed our first resistor pin, we will also connect to the digital input, which would be output. So as you can see, we have over here, let me show you the numbers so we can get light on that side. So apparently we can. Okay. So the red is connected to the 9 slot. It has to have the tilde for the PWM, which is pulse width modulation. It simulates an analog output. What this will do is connect and set the dimmer that is required for the dim feature. It would set it to the value of this potentiometer using the software. So then what we have to connect is just the potentiometers themselves, and the purple is the ground, the negative ground. So it connects to one of the double poles. You can see it has 2. So one would be the negative, the other would be the positive, and on the opposite side we see there's only one pin, so that pin should go to the analog input. So each one has its own. It's A0, A1, A2, as you can see from over here. So this would be red, green, and blue, and finally just the 5 volt over here and ground to give it the AC, the electricity to the circuit. Oh, forgot. We need a button. What this button will do is, as soon as we press it, it would calculate the value of the color and convert it into hex. So it's gonna display on the computer. And how to connect this button is it has 2 poles on one side, and what we're gonna do is connect one side directly to the ground, to the positive, which is this white cable, and the purple again is the negative. So that is our ground. Let me give more light here. So that is our ground, and it needs a 10K ohm resistor. So the negative side would connect to the digital output where we want the button to trigger, and the 10K would go to a new slot, and then from there it would go into the negative ground, and we just have to show it working. So let me dim here the lights. Let's get a good RGB value and secure everything. Everything is got to put the knob back in. There we go. Let me reduce green just a tiny bit. Reduce blue too. That's fine. And then let's up red. Yeah, red's as high. Oh, this is not well connected. There we go. Shit. Please, excuse me. I'll get this. Alright, so we got a hex value there. We see we have a little red, a little more green, and quite a bit more blue. So let's see what that would go. What we're gonna do. Let's open the Arduino software right here. Yeah, thank you, Mango, for the background. Okay, so this is our Arduino software, and let's verify it before uploading. So we uploaded our code, and now just to demo it out to see what it should do, we open the monitor, we pull this down, and okay, so now we would press the button over here, and we should see a hex value on that monitor, and we do. So our hex value is 0214. That will be a hexadecimal value. Let's change up the numbers to just to verify that we're getting letters and nothing is breaking. Okay. So let's clear the console again. And then we press it again. We get a new value. Boom. And no letters this time, so that's weird. It's trial and error. It's up red. That should put in a little more. That's it. It's the red. If the knobs want to stay on, keep them down. Alright. Okay, so first let me open this. Now we should press a button and we see a letter finally. F12136. That would be the hex color for this this light. And yeah, I had to spike the red. Yeah, that got the letters out. So yeah, you see, these are funny, but whatever. Alright, so that's my lab. If you want to see the code, it's pretty simple. What we do is we initialize and just store the values for the input and outputs where the slots are connected physically. Then we set our button up, set our status to 0, and in the setup, sorry for that, we begin the serial so that we can display over here later. We then configure the outputs to the pins so that the lights actually turn on. Configure the button also and set it to pull up. That is so that we get to print just only once eventually soon. So the void loop starts, and what it does, it gathers first the value using an analog read from the red potentiometer, the green potentiometer, and the blue potentiometer. And since it gets the potentiometers really have a value of 0 to 1023, we have to divide them by 4 to reach that 255 value. And what we do now is set the light bulbs to each potentiometer's value. So red light bulb gets the red potentiometer value, green light bulb gets the green, and so on and so forth. Next step would be to get the string value, and to do that we use the string command and make sure that we specify to bring it as a hex value. And if we know hex values use 6 characters, the first 2 represent the red color, the second 2 represent the green color, and the last 2 represent the blue color. So now an if statement checks if the button is set too high. So if it's pressed in the status read low from before, then what it does is it prints out the red, and next to it prints out the green and the blue, making a full hex color. Then it sets the status back up so that we can press again eventually. So this is what it prints out as soon as we press that button. The if statement triggers, and it brings the 3 pieces of the hex value and writes them all sequentially so as to look at its one hex value. That's the lab. Hope you enjoyed it. Thank you.